All right, sixth graders, we're going to go through some solutions for you on the sheet we had from yesterday, volume of rectangular prisms. So remember, we look back at the different things we've done with our geometry unit. We started off talking about perimeter, which was the distance around the outside of something. I said perimeter, you think of a fence. The area, which is now, we're no longer talking about linear units like we were with perimeter. Now we're talking about square units, where we are going to find how many squares it would take to cover something, how many 1 by 1 squares. Okay, that was area, and then we moved, so perimeter was a fence, area we said think floor tiles. Then we went into surface area, which we wanted to think about wrapping paper then, like how much paper would it take to cover up all the sides, all the faces of a three-dimensional shape. So we're still dealing with squared units there because the total surface area was just the area of each of the faces of our 3D solid added together. And then yesterday we started talking about volume. So we said when you think of surface area, you think wrapping paper. When you think volume, you got to think sugar cubes, because now we're talking about a different unit, again in cubic units. Anything that would be a 1 by 1 by 1 cube, and in this example we had yesterday, they were centimeters, so 1 centimeter by 1 centimeter by 1 centimeter cubed. How many of those cubes would it take to occupy that same space as the prism? And in this case, we're working on rectangular prisms. We know that the formula for volume is a volume equals area of the base times the height. But for a rectangular prism, that's really easy because the base is a rectangle. So it's the area of that rectangle, which could be defined as length times width, times the height of the prism. And that's the distance between the two parallel and congruent bases. So I did some of these with you yesterday in the video where I was explaining volume. We identified the length, the width, and the height, okay, for this number 1 here. And then we found the surface area, because it next says 1, 2, and 3, or it said find the length, width, and height, find the surface area, or how much it would take to make a box around it that's like wrapping paper, right? And then find the number of cubes in each one of these prisms, and in this case that means volume, right? So to find the surface area, that hasn't changed from everything we've been doing for the last week or so, actually more than that. We're going to find you pick wherever you want to start. I chose to start with the front here. We had a 3 by 1 rectangle that made up the front of this prism. So that's 3 times 1, or base times height is 3 times 1, or 3 square inches for that first front side. And then we know there's also a back side that we can't see, but it matches. There's 2 parallel and congruent faces on either side, right, opposite of each other. So I multiplied by 2, we had 6 square inches. We did the same thing for the left side. That was 5 by 1 multiplied by 2, so that took into account the right side. And then the top and bottom, we can count the top, right? We can see the area of the top here. It's 5 by 3, or 15 square inches. But there's also a bottom we can't see, so we multiply by 2. And we add all those up, you get 46 square inches for the total surface area. That's how many squares, flat squares it would take, 1 by 1 inch squares, to cover that rectangular prism. So for volume, you can actually count the volume here. When I said you can count the area of that top, that's really counting all the squares in this prism. But again, volume is area of the base times the height. And so that rectangular base, the formula for the area of that is length times width. So volume equals length times width times the height of the prism. And so we have a length of 5, right? A width of 3 and a height of 1. So 5 times 3 is 15, and 15 times 1 is 15. So we have a volume of 15 cubic inches now. So make sure you have a 3 there for your label. You're cubing those inches. Number 2, I started with you, and I'm going to kind of skip through this. Like, I'll leave it here for a second if you need to pause our video and see the answer, but that's all the same. Front, back, left, right, top, bottom. Followed the exact same process to get 62 square inches. But for volume, I did mention this yesterday in our video. Like, you can count this top row again. I can see there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There's 15 cubes that make up that top layer. And then there's just a second layer, right? So the 5 times 3 is that length times width to give me the 15 cubes. And how many high are we stacking them? Well, we're stacking them 2 high. So 15 times 2 is 30. So that's another way to really see how that formula of volume equals length times width times height plays out. It's pretty obvious there. And in the next example as well. because we're still dealing with the same footprint. It's still that same 5 times 3, or if you look at the top layer, you have the 5 times the 3, so there's 15, and now we're just seeing how many layers are there. So there's 1, 2, 3, 4, 5 of those 5 by 3 layers, or again, if you do 5 by 3 is 15, so that'd be 15 cubes times they're stacked 5 high. That's where I get a volume of 75 cubic inches for number 3. And again, I'm not going to talk you through all this. Again, for the surface area, I'll leave the screen here for a second if you want to pause it and see some of the work that's there, but it's top, bottom, or I'm sorry, front, back, left, right, top, bottom again. Same for number 4. Now, this one I did do in the video again yesterday. So they took out the individual cubes, and they're just telling us now you have a base of 4, or a length and a width of 4 and 2 for like the footprint again, that bottom rectangle, that area of the base would be 4 times 2, or 8. And then the height of the prism this time is 4, so 8 times 4 gives us that 32, and that would be 32 cubic inches for the volume of this particular rectangular prism. And the surface area, again, is all the same that we've been doing for a couple weeks now. To find the top and multiply it by 2, so we account for the bottom, find the left, and multiply it by 2 for the right, and find the front, and multiply it by 2 for the back, okay, and add all those together. That was one step some of us were missing, is adding them all together for the total surface area. And that takes us to this last problem here. It's a taller, skinnier prism that we have, but it's the exact same process for finding. I mean, it could take you through finding the surface area again. Maybe you got a calculator out on some of that if you needed to, because we had some decimals involved here. 13.5 plus 90 plus 30. Notice this is still squared inches, because I'm still finding that wrapping paper idea, like how many 1 by 1 inch squares would it take to cover all of the surfaces, all 6 of these faces of our rectangular prism, and it would take 133 and 5/10, or 133 and a half square inches to cover all that. So that's our surface area. And for the volume, again, I'm finding the volume by taking the area of the base times the height, or we're doing length times width times height. So it's length, or length here, if you want to call it the 4.5 your length, times the width of 1.5 times the height of the prism, which is the distance between the two parallel and congruent bases. So we have volume equals 1.5 times 4.5, length times the width, times 10, which actually is kind of nice. I had already done that calculation up here, 1.5 times 4.5, and I knew it was 6.75, so then I just slid my decimal one here, 67 and a half cubic inches. Remember, we're dealing now in sugar cubes here. When you're thinking about volume, you're thinking about how many of those cubes would it take to account for the same amount of space as this prism. That is today's assignment corrected, or yesterday's assignment corrected, volume of rectangular prisms. Please reach out on WebEx or through Google Classroom or email if you're having any trouble with this. And please go ahead and submit this back to Google Classroom. You can send it right from Notability. If you're having any trouble with that, please reach out as well. I have a tutorial for how to work from Notability back to Google Classroom in the works, and we'll get that shared out as well soon. All right, have a good day.